Hi, my name is Volodymyr Kyrylov, and I'm proud to be sharing and presenting our work with Dmytro Chaplynskyi on GPT-2 metadata pre-training towards instruction fine-tuning for Ukrainian. In this work, we explore pre-training a single, multitask, larger language model on a compute budget. We leverage fiction Wikipedia and use a subset of UberText 2.0 collecting over 4 billion tokens. We use metadata by prepending it as headers and footers for each document. This way we would like to achieve metadata conditioned document generation and document conditioned metadata prediction. This way we unlock tasks such as text summarization based on predicting titles from the documents and zero-shot text classification by predicting tags. We train 3 models, GPT-2 small, medium, and large. Small and medium are trained on 3090 NVIDIA GPUs, and large is trained on a single A100. To perform intrinsic evaluation of our models, we take almost 29,000 sentences from Brown corpus of contemporary Ukrainian, making sure we do not have overlapping sentences with ubertext, and report bits per character. Our largest model achieves the best performance on this task. We also report metadata prediction results by downloading 1,000 news from the future past the cutoff date of UberText 2.0 and measuring bird score and BlueRT on texts that are predicted by the model and ground truth titles. We also compared our model's performance towards a strong encoder-decoder model that's fine-tuned on 1,000 news articles from UberText 2.0. We also report accuracy and intersection over union on tag prediction for zero-shot text classification. Now, we consider performing classical named entity recognition task that's usually done as a sequence tagging problem as text generation. We reformat named entity recognition dataset by putting a sentence, then a task label, and then the sentence was interspersed, begin inside, outside, like entity tags after every word. This way we can train using the same language modeling objective we were using before for pre-training. And we add this task to our current model by training a low-rank adapter. This is an example of what a task example looks like. We have a sentence, a task label, and words interspersed with tags. When we train on this dataset and perform testing, we see that the model is sometimes drifting away from the sentence itself, forgetting what it seems supposed to be doing. And we decide to fix this problem by constraining decoding. We give it words and a tag prompt and decode a single token for the tag and continue decoding like that. This way we're able to conclude our evaluation and report results alongside other bidirectional models trained specifically for sequence labeling and not for language modeling based text generation. We do the same experiments for part of speech tagging. We add another adapter and add dataset formatted in a very similar way, except during decoding, instead of forcing it to give us word-by-word tags, we give the whole sentence at once and replace all tags with blank characters, and then we forward all tokens through the model and decode all tokens at the same time. We're able to report results this way alongside other models trained specifically to perform sequence tagging. And now, in conclusion, we are able to pre-train larger language models on a single GPU in under a week. We add more tasks to this model using adapters in a very short period of time. We're using the same objective to perform these tasks, and we show some tricks how to help the model finish them without breaking the structure of the problem. We are releasing these models to the community. We're open sourcing the code, and we are thankful for your attention.